All right, let's jump further into our discussion of statistics. And we will talk about two of the bedrock features of statistics, and those are reliability and validity. Any measure of psychological characteristic or any assessment of variables must show reliability and validity. Now, these are two different concepts and two different terms, so we're going to take them one at a time. And we'll start off with reliability. Reliability refers to the consistency of people's scores on a test. This can be assessed in a number of different ways, meaning how reliable and how dependable will a score be over time can be tested in different ways. The first way, and by the way, a test does not need to be valid in order for it to be reliable. There are, again, two different measurements. So let's start with talking about test-retest reliability. This refers to the consistency of scores across different administrations of a test. So if you're taking the test on more than one occasion, the question is, do people get about the same score the second time that they take the test, compared to the first time they took the test? When an adequate number of people have taken a test twice, the researcher developing the test can then compute a correlation coefficient between the two sets of scores, meaning the first set of scores and the second set of scores across the various people who have taken that test. Now, if the correlation coefficient is larger than about 0.70, positive 0.70, that is a pretty good indication that the scores from the first test are correlating to the scores on the second test, and therefore we can say that the test has a high degree of retest reliability. Now, of course, the measurement of reliability, of test-retest reliability, depends on the type of test we're talking about, what we're measuring, and what the scores are being used for. Moving forward, the reliability of self-report measures is typically described in terms of internal consistency. Okay? And internal consistency is how well does the test correlate with itself internally, right? Not compared to a single person taking the test multiple times, but within itself, does the test at the beginning, when it's asking a set of questions, is it reliable with what we ask at the end of a test, for example, internally? And this is assessed using the split half reliability measurement. So for each test taker, let's say I'm taking a test, a score is generated for, let's say, all of the even numbered of test items in the test. And perhaps I simply total up all of the scores of the even numbered test items, as well as for the odd number items. And eventually I will create or produce a correlation coefficient across the two sets of scores. So I have the even numbers here, I have the odd numbers here. So I'm going to look at my scores on numbers 2, 4, 6, 8, and 10, and compare them to obviously 1, 3, 5, 7, and 9. And I total up the scores, and I compare to see how well do they coalesce with each other, how well do they correlate. Thanks to math and to computers, the split half reliability of a test can actually be calculated as the average correlation for every possible way of splitting the test in half. And this measurement is what we call the Cronbach's alpha, hidden right in there. Okay? So the Cronbach's alpha is the average correlation of every single way that a test can possibly be split. So it would actually be hard to do just by hand, but it's a very advanced measurement. Now, let's move on to talk about validity. Validity refers to how well a test measures what it proposes that it will measure. Okay? So if a test says that it's going to measure the ADHD level in a person, how much ADHD does a person have, if they have it at all, or how much anxiety a person experiences, and a test says, we think this test measures anxiety, validity lets me know how well does the test measure what we are proposing it measures. So if the reliability of a psychological test is low, it can't possibly measure what it's supposed to measure, and basically some enduring stable psychological characteristic. Thus, it can't be valid if it is not reliable. Again, a test cannot be valid if it is not first reliable. So first we have to establish reliability, and then we can establish validity. Okay? However, the same is not always true in the opposite. Being reliable is not a guarantee that a test is valid. It could be measuring the same wrong thing over and over again. So for example, if a personality test has people rating how much they gossip, it's possible that individuals would get the same score every time they took the test, which would indicate that it's reliable, right? Every time I take the test, it reliably tells me that I gossip. However, these scores could merely be reflecting how concerned I might be about coming across well on that personality test, meaning I might be faking it on that test. And so if I'm faking it, then it's not really going to be a valid measure, right? And it would have very low validity. Okay, so now that we understand the basics about what validity is and how it compares to reliability, let's talk about several ways for us to assess validity. Okay, we'll start off with talking about face validity, or otherwise known as content validity. So face validity or content validity refers simply to whether a test looks as though it is measuring what it is supposed to measure. This is fine for, say, a driver's test, right? Because if I'm going to test a person's ability to drive, I want to make sure that it's really testing my ability to drive, right? So at face value, if it says it's going to test my driving abilities, I really want it to measure my driving abilities so that there aren't accidents all over the streets. But the same is not true for most psychological tests, okay? I don't necessarily want the people taking the psychological test to be able to figure out what I am actually measuring. So it gets a little tricky. Predictive validity, on the other hand, refers to how well scores on the test predict the actual behavior of the type that the test is supposed to measure. Okay, so again, this is about testing. Does the test predict well what behavior it is that the test is saying it will predict? So maybe it's an aptitude test. If a test says that I think from this test I can predict how good of an accountant you'll be, that's what this test is going to tell me. So I need to measure how predictive and how valid it will be for measuring one's accounting abilities. Next, let's talk about, that's predictive. Now let's talk about construct validity. So construct validity refers to whether the scores on a questionnaire are related in expected ways, either positively or negatively, to scores on other questionnaires that are proposing to measure the same thing. So if I have measurement A that's going to assess, let's say, my athleticism, and then I'm going to have test B and test C, I want to be able to compare how well A does in its predictability to what B says and C says about my athleticism. Okay? Other tests, by the way, or rather I should say tests in general need to be standardized. If I compare them to a large number of people with the known characteristics, such as a person's age, or their race, or their sex, I want to be able to standardize the test in order to make it possible to determine how well a single person will perform relative to those in the larger group who have taken that particular test. Knowing how many problems that I've gotten right, for example, on an intelligence test, is meaningless without knowing how well other people my age are doing on that same type of intelligence test. So that helps me to standardize the measure and determine whether it can be effective as a measurement. All right, so that was a lot of information about reliability and validity, which are again the bedrocks for statistical analysis. We have a few more topics to talk about in this area, so take a break and we'll see you in just a few moments.